Hello class, today we're going to be solving 1.1 part 3. We stopped at question number 14 and so with question number 14 we have 4 multiple choice answers and all of them are tables, A, B, C, and D. But before we look at the tables, let's first understand the question. And we have a decreasing function that has the following property, that for all real numbers a and b in the domain of f, if a is less than b, then f of a is greater than b. Let's forget the second part of the question. Let's just focus on the first. Now, what does it mean for if a is less than b, then f of a is greater than b? Let's set up a table and understand this really quick. Why did I draw an ugly table? Okay, never mind. So we have 1, 2, 3, and 4. Okay, there we go. Okay, so we have, let's say this is x and this is f of x. Okay, this is f of x. 1, 2, 3, 4, and 5. Let's go with 7, 6, 5, 4, and 3. Okay. Now, as we move on with the x values, what can you tell? They're increasing, right? But as we move on with the y values, or f of x, they're decreasing. So what does that mean? As we move to the right, remember when I have an xy plane, I go from left to right, correct? We always move from left to right if I want to read a graph. Now moving from left to right, this function is simply decreasing because the y values are decreasing. And a decreasing function could either be concave up or concave down. Now, what do I mean by concave up or concave down? Well, its concavity will be facing upwards. Let's have a look at a decreasing function that's concave up. You can tell that the y values are simply decreasing, right? As we move from left to right, the y values are are decreasing. Y is simply decreasing. This is concave up. Now let me give you another function where the y values are also decreasing, but it's concave down. See this function? It could start at this point, down to this point. This is decreasing, but it's concave down. Are we searching for that? Not really. We're searching for a function that is concave up and it's decreasing. So to make life easier, what we're going to do right now is to write down all the cases of concave up and concave down and decreasing and increasing. So let's say we're dealing with an increasing function where the y values are increasing. Case number 1 would be concave up, let's say. So it would be a function that looks like this. Concave up, the y values are increasing. I suggest you memorize the shapes, right? So they wouldn't mention that Well, an increasing function has nothing to do with whether a function is concave up or concave down. So if they tell you a function is increasing, then it may be concave up as case number 1, or it may be concave down as case number 2. Both cases, 1 and 2, lie under the fact that they're increasing. You get it? Concave up and concave down has nothing to do with whether a function is increasing or decreasing. But let me tell you what are the keywords that tell you, that would specify, that would clarify on whether a function is concave up or concave down. It's the word rate of change. Whenever you see the word rate of change, this basically means that, if a rate of change is increasing, then it means that the function is concave up. It doesn't matter whether the function is increasing or decreasing. Whenever you see the word rate of change increasing, it means that it's concave up. What if you see the word rate of change decreasing? Then it means it's concave down. Now we're going to keep the table because we're going to use it in a bit. But let me go over the decreasing y values. Let's say we're dealing with decreasing y values. Case number, do you want to call it 3? Let's go with 3. This is a function that's decreasing, right? Now, what's the concavity? It's concave up, right? So guess what? Even if the function is decreasing, the rate of change is increasing. Now, you may ask, oh, why is it increasing when a function is decreasing, right? That's a good question. Let me tell you why. Let's say you take this point right here and you draw a straight line just passing through this point. What does rate of change stand for? Well, it stands for the slope. If I want to find the slope of this line, well, it's going to be a steep negative number. Let's assume it's -7. Let's say I take another point over here and I draw a straight line passing through it. Assume that it passes through it. And I want to find the slope of this line. Well, it's not going to be that steep. It's still going to be negative. Slope will be probably like -1/2. Now, if the slope was -7, now it's -1/2. Didn't it increase? Didn't the slope increase from -7 to -1/2? Because -1/2 is greater than -7. So that means the slope is basically increasing, although the function is decreasing. So whether the function is decreasing or not has nothing to do with the rate of change, which is simply the concavity of the function. If the rate of change is increasing, that means the concavity is facing upwards. Now, last but not least, case number 4 is a decreasing function where you have concavity downwards, and take a guess, the rate of change is decreasing. Now, let's take this point over here and draw a line. Well, remember the slope, let's assume the slope equals to negative 1/2 as well. And then we take this point, we draw a line. The slope equals to -9, let's say. Going from negative 1/2 to -9, isn't it simply decreasing? So in this case number 3 and case number 4, both are functions that are decreasing. The function is decreasing. Y is decreasing, the function is decreasing. But the rate of change with case number 3 is increasing, and the rate of change with case number 4 is decreasing. Now, what does that have to do with the equation? Let's have a look. They mention the decreasing function. So am I looking at case 1 and case 2, or case 3 and case 4? Well, since it's decreasing, it's obviously either case 3 or case 4. And they mention that, let me place this on Do Not Disturb really quick so nobody disturbs us. Now, back. Okay, so what do we have? They mention that if A is less than B, then f of A is greater than f of B, right? And that is true with this table. A, let's assume A equals to 1, B equals to 2. What they're trying to tell us is that A is less than B. Yes, it is true 1 is less than 2. And it is also true that f of 1, let me write that down, is greater than f of 2, right? What is f of 1? Isn't it 7, which is greater than 6? So you're basically searching for a table where the x values are increasing, but the y values are decreasing. So if you ever end up with a question like this, where you have A less than B, f of A greater than f of B, well, you just form a table on your own, you set up some values, and determine whether your table is correct or not. And if it's not true, then you just switch up the numbers. Moving on, in the xy plane, the graph of f is always concave up. I know it's either case 3 or case 4 since the function is decreasing, but they mentioned the word concave up, so that basically means the rate of change is increasing. And of the following, which is a possible table of values for f? I know the rate of change is increasing because it's concave up, and I'm also searching for a table where as x increases, y decreases. Let's have a look at the first table. As x increases, well, y decreases, so it could be option A is possibly correct. What about the second one? As x increases, y decreases, it could be B. What about C? As x increases, y increases. I'm sorry, C. Well, it's obviously not C, right? We're searching increase, decrease. Now, last but not least, option D, as x increases, well, y decreases. So it's not, I'm sorry, what did I just say? It's possibly D. So if I have positive, or like, well, by positive I mean as increasing, then it's not the answer. It's either A, B, or D. Now, how do we determine? Well, I know that the rate of change is increasing, so what does that mean? The slope is increasing. So we need to take the first 2 points. Let's take 6, I was about to say 6, 7. I'm going to say 6 and 7. So we're going to take 6 and 7, so 6 minus 7, divided by 0 minus negative 1, which is, if you do the math, it's going to be negative 1 divided by 1, which is negative 1. Now for it to increase, the next number must be a value larger than negative 1. So it could be, let's say, negative 1/2, it could be 0, it could be 1, it could be 2, for the slope to be increasing, right? The rate of change is increasing. Let's test that out with the second slope. If I do 4 minus 6 divided by 1 minus 0, it's going to be negative 2 over 1, which is negative 2. We'll take a look. The first slope was negative 1, the second is negative 2. Is the slope increasing or is it actually decreasing in this case? Right? So it's not option A. And I know it's not option C. Well, I'm just let down to B and D, right? What about option B? Well, we have 5.35. That looks like a 6. 5.35 minus 7.05 divided by 1. 2 minus 1, right? What's the answer? Let me pull out my calculator because my brain isn't functioning at the moment. Let me see. 5.35 minus 5. Okay, so this is negative 1.7. Now, from 2.65 minus 5.35 divided by 3 minus 2, what am I gonna get? 2.65 minus 5.35, well, it's negative 2.7. So it's basically decreasing, and it's not the answer. Well, I'm gonna solve option D, just for the sake of practice. We have 1.87 minus 4.34 divided by 8 minus 7, which is, if we do the math, we're gonna get negative 2.47. Now if the next number is larger than negative 2.47, so in terms of negative numbers, it could be like negative 2, negative 1, negative 1/2, then you could move on to 0, and then like 1, 2, 3. Any of these would work, right? Because then the slope would simply be increasing, which means the rate of change is increasing. Now let's test that out. We have 0.8 minus 1.87 divided by 9 minus 8, which is simply equal to, if we do the math properly, it's negative 1.07. Now have a look. It was negative 2.47. Now it's negative 1.07, which definitely means that the rate of change is increasing, which means it's option D. Now that question took us some time, but it was because we were explaining case 1, case 2, case 3, case 4. We went over the tables. So yeah, good. It's good practice though. It basically gives you all the fundamentals you need to solve a question related to concavity, whether it's upwards or downwards, and it was good practice, I would say. Moving on to number 15, which is a very silly question, maybe. Okay, the figure shows the graph of a function f, and we have a 0 going on, You have some extreme points going on and extrema. And we have a point of inflection. So what's a point of inflection? A point of inflection is when the function goes from concave down to concave up, or from concave up to concave down. Let me explain this one more time. So let's say a function is concave down, then it goes concave up. In this case, this would be a point of inflection. Let's say it's concave up, then it goes concave down. You see this point, it's a point of inflection. So it's basically the point where the rate of change, what happens to the rate of change? It changes basically. Not sure why that, yeah, so when the rate of change changes. Now, who can tell me, I suggest you pause the video. Does the rate of change go from increasing to decreasing or decreasing to increasing with the first case, which is number 1? And what happens in the second, number 2? I'm assuming you paused the video. I hope you did. But with the first case, the concavity was upwards, right? So it goes from increasing to decreasing. We just covered this right now. Rate of change is increasing when it's always concave up. And it's decreasing when it's always concave down. With the second case, since it's concave down, it went from decreasing to increasing. That's it. I hope that makes sense. Now, it's not always the case. It could look like this. Have a look at this concavity 1 second. So, I'm sorry. Yeah, have a look at this graph. Oops, what was that? Oh, we have stickers as well? Okay, anyways. So let's say we have a function that, well, this is what? This is decreasing, right? And then it moves on to increasing. So it's not always well, it's either going to be increasing or decreasing or decreasing, increasing, but it doesn't have to start like from the top, you get what I mean? You could have variations to it, but it's either going to be increasing, decreasing, or increasing, or decreasing, increasing, and that depends on the concavity. I've never seen a question where they asked, well, it might happen, like don't take my words for granted, but I've never seen a question where they ask on how the rate of change behaves at the point of inflection, but it's good to know because you don't know what to expect on the AP test. And anyways, back to the question. We went off topic. It's not off topic, we're still solving AP content, but yeah. And the point of inflection is C, right? And we have points A, B, C, D, and E, which represent x coordinates at those points. Of the following it is useful. On the following, on which interval is f increasing and the graph of f concave down? So we have a function, f of x is increasing, but the concavity is downwards. Well, let's go back to what we just took. 1 second. It's increasing. You see this? The f of x is increasing. You could call this f of x. Why did I name it y from the first term? Okay, anyways. The function is increasing, but what's going on? They mentioned it's concave down, so the rate of change is decreasing. So you're looking for a function that looks like this. So let's go back. Okay, my iPad glitched for a second. Let me just, there we go. Okay, so where is it concave down? Well, this is concave down, right? And it's increasing, but concave down. That's what we're searching for, basically. A and B, that's the answer. A to B, I'm sorry. What about B to C? Well, B to C is definitely concave down. The thing is, f of x is decreasing, and we're not searching for that. We're searching for a concave down increasing function. And what about C to D? Well, C to D is concave up. It is true the function is decreasing. I'm sorry. Yeah, it's decreasing. They're searching for increasing as well. Anyways, it's decreasing and concave up, so this one's out. And what are we left with? We're left with D to E, which is out as well because it's concave up and we're not searching for that. The function is increasing from D to E, but it's concave up. Now last, I was gonna say last but not least. I'm sorry, no, we have a lot more questions. Okay, number 16. An object travels along a horizontal line with velocity given by the function v. The graph of y equal to v of t, which consists of 4 line segments, is shown. On which of the following intervals is the object's velocity decreasing over the entire interval? Well, it is decreasing from 0 to this point, that's what I can tell. And it's decreasing from 8 to 10. That's it. So from 8 to 10. And I have from 0 to 3 and 8 to 10. Yeah, so it's option D. That is it. Hope that makes sense. So this one is pretty straightforward. There's nothing, there's not much to it. We can move on. What about question number 17? We have the depth of water in feet at a certain place in a lake is modeled by a function w. The graph of y equal to w of t is shown, where t is between 0 and 30 inclusive, where t is the number of days since the first day of the month, what are all intervals of t on which the depth of water is increasing at a decreasing rate. Whenever I see the word decreasing rate, that means it's concave down. Concave down, right? So it could either look like this or like this. But the question is it going to be case 1 or 2? Well, the depth of water is increasing, so that means the function is definitely increasing, so it's the first one. That's it. I hope this makes sense. Now we're looking on the graph. We're searching for a similar shape to case number 1. Well, what is 3 to 6? Well, that's the answer, basically. It's increasing at a decreasing rate. Increasing at a decreasing rate. See how easy it is? So A is true. What about 3 to 12? With 3 to 12 now we have a collection of increasing and decreasing, which is not the case. 0 to 3, well, with 0 to 3 it's increasing at an increasing rate. It's increasing and it's concave up at an increasing rate. But that's not the answer, so we don't really need to check 18 to 30. What about 0 to 6? Well, we have an increasing and a decreasing rate going on, which is not the answer. Moving on to this question. Figure shows the graph of function g. The endpoints of the interval are labeled with points A and E. You have two other extrema for g, which are labeled points B and D. Point C is the only point of inflection of the graph of g. As you can tell, it was increasing, now it's decreasing. Although the function is still increasing, f of x is still increasing. It's just that the rate of change changed, basically, from increasing to decreasing. And of the following, on which intervals is the rate of change decreasing? Well, I know the rate of change is decreasing from C to D. I know it's also decreasing from D to E because that's also concave down. So I'm basically searching for the concave down shapes. And that's when the rate of change is decreasing. So C to D and D to E. So it's option D. Now, what about question number 19? A car is traveling on a straight road. A graph of the car's position in miles from starting point at time t equal to 0 hours on a particular day is shown. Which of the following is true about the car's position for t between 0 and 3? Well, where is 0 and where is 3? Oh, so from the very start to the very end. It starts at 0 and ends at 3. Well, the rate of change of the car's position is increasing until about t equal to 1.25. Well, the rate of change is increasing. Why? Because it's concave up. So, yes. When the position begins to increase at a constant rate. Oh, this is really good. You see this? It's a straight line, right? Whenever you have a straight line, remember, it has a constant rate. Why? Because the slope isn't changing. When I have y equal to mx plus b, isn't m simply fixed? Well, y equals to 5x plus 3. If I want to plug in points, I would only plug in for x and y, right? Does 5 ever change? No. Why? Because it's a constant rate. So whenever you see a straight line, whether it's increasing or decreasing, the rate is not decreasing or increasing. The rate is constant. It has a constant rate. Yes, the function is decreasing, and yes, the function is increasing. But guess what? It's increasing at a constant rate, and it's decreasing at a constant rate. The rate on how this function is decreasing or increasing is not changing. And it would only change on whether it's curved, right? It could be curved with a concavity that's upwards, which means the rate of change is increasing, and the opposite is true. And what else do we have? Oh yeah, we went off track, but I believe that answers the question. The rate of change of the car's position is increasing until about t equal to 1.25. Yes, it has a concavity which is upwards, and then we have a straight line, which means it's a constant rate, so it's option A. Let's have a look at the other answers though. The rate of change of the car's position is increasing until about t equal to 1.25, which is similar to option A. After this time, the position is constant. Is the position constant? No, the position is still increasing. It was at 90, now it's at 120. The position kept on increasing. The function still increases, but at a constant rate. So B is out. And what about C? With C, they're mentioning that it's concavity. The concavity is upwards for the whole interval. And that is definitely not the case. So C is out. What about D? Oh, they're saying that it's increasing at a constant rate, so it's always straight, and that's not the case as well. And yeah, that was it for 19. We have question number 20 left. And we can, give me 1 second really quick. Okay. Anyways, back to question number 20. Now, what about this one? The figure shows a container in the shape of a circular cone. The container is being filled with water at a constant rate. So the water filled in the container is filled at a constant rate. But the question is on how fast is the container filled up? Would that be a constant rate? Which of the following could be the graph that models a dependent variable of the depth of water in centimeters as a function of the independent variable of time in hours? So if I want to measure depth of water in relation to time, wouldn't the depth basically increase at a faster rate at the lower part of this container compared to the top part? Why? Because it's more narrow towards, I would say, the bottom part compared to the top part. And how would I graph this, right? Well, what would you say? Would you say that we have a decreasing rate as we move upwards or an increasing rate? So let's say it takes me 1 minute to fill up this part. Wouldn't it take me around 4 minutes to fill up the top part and then like 10 minutes to fill up the last part, right? So isn't it taking me more time to fill up this container, which means the rate is simply, now you might say increasing, but no, it's decreasing. The rate on filling up this container is decreasing. Now you may, well, if you're still lost, let's actually form a table. To fill up to depth of this container, 2 meters, it took me at first 1 minute, right? And then to fill up to meter number 4, it's gonna take me 4 minutes. Now going from meter number 4 to number 10, it's gonna take me, let's say, how did I say? Okay, so from meter 2 to meter number 4, okay, let's say meter number 6. It's gonna take me around, let's say, 12 minutes. The more I move up, the more time it's taking. So let's find the rate of change. Well, 12 minus 4 well, let's start with the top one. 4 minus 1 divided by 4 minus 2, which is simply 3 divided by 2, right? The rate will simply be decreasing. So 4 minus 1 divided by 4 minus 2. Now let's go on to the second. 12 minus 4 divided by 6 minus 4. Isn't this simply equal to, doing the math really quick, we got 6, 8 divided by 2, which equals to 4. Okay, we should have increased the values. Okay, let's go with meter number. Okay, I have to change the number. I'm sorry about that. Let's go with meter number. Let's go with meter number 15, let's say. So if I do 15 minus 4, what do I get? Let's erase this. We got 6, 8 divided by what is 15 minus 4? You got 6, 9. Okay, so 8 divided by 9 and 3 divided by 2. Well, it's definitely decreasing. Now, I'm pretty sure you're not gonna like come up with numbers and all that on the test. What I would say is just by looking at it, wouldn't you tell that to fill this up as we move upwards, that the rate will decrease? I believe you would be able to tell that just by looking at the graph, looking at the container. Plugging in numbers might be a bit confusing, as you could tell from the first try I didn't get it correct. So if I don't have a good understanding of what's going on, I might actually end up with the wrong answer. Did I just delete it? Was it at the end? Anyways. Yeah. So, where were we? Yeah, it has a decreasing rate, so that means its concavity will be downwards, and that is basically option C, and that's your answer. So that's it. Yeah, thank you for watching. Hopefully we'll see you with another video today, maybe. We'll see. Okay, thank you, bye bye.